Okay, hi everyone. Now we are at question 4. Question 4 is very different from question 1, 2, and 3 because you are now given a solid. Okay, so for this solid, right, taking a look at the color, I think it's quite obvious, right? It is a green powder. Okay, now knowing that it's a green powder, we need to make a guess that, what are the ions present and what may not be present. Okay, so it's very obvious the one that are the colorless ions, they will not be present. So same thing, right? Like a Pb2 plus, your zinc 2 plus, your ammonium, right, and calcium 2 plus. The colorless ones, they are not present, they are absent. While it is possible to be Fe2 plus, Fe3 plus, and Cu2 plus. Okay, now for this one, I need you to be very careful because I think that many of you will see that, oh, green, so this must be Fe2 plus. Okay, but do not be so sure, right? Because for Fe2 plus to be green, it is only when it is a solution. And in this case, it's not a solution, right? In this case, it's a solid, so you cannot be sure, right? You cannot be 100% sure. Okay, so you got to do the test, which you can see in test in B and C, where we confirm the different types of ions present. So we look at what we are doing for part B, right? What we are doing for part B is that we're going to transfer the solid, right, into a boiling tube, and then we're going to heat carefully until no further change, right? This is actually what we call as thermal decomposition. That means we use heat to break down something, right? We're using heat to break down something. And when we use heat to break down something, what we are producing is actually a gas. Okay, so we got to use test for gas. And what gas that we're testing for actually is super obvious, because what are you preparing in another test tube? You're preparing lime water. So once you see a lime water, then you know that you're testing for carbon dioxide already. Okay, so what you're doing in this experiment is that when you're heating, you use a tip pipette, and a tip pipette is what we commonly known as dropper, right? We use dropper to actually draw the carbon dioxide that is being formed, and then to bubble the carbon dioxide into the lime water. Okay, so what would you notice? Okay, now there are 2 marks for this question. That means they are looking for 2 observations. Now one would be very clear. I believe that when you look at your lime water, you see that there's white PPT, so you can just write down white PPT in lime water. That will give you 1 mark. But how do you secure the other mark? Now after you do your heating, what happened to the solid? The solid at first was green, right? At first it is actually a green powder. At the end, what color did it become? Right? It becomes black, right? Upon the strong heating. So this is something that you need to write down, right? As the other observation that will give you a 2nd mark. Okay, so what we can confirm from here, right, is that through this heating, right, the gas that is produced is carbon dioxide gas. And because we know that it's carbon dioxide gas, we can confirm carbon dioxide gas comes from which ion. Okay, so if you go back up to your anion test, right, carbon dioxide gas is usually linked to carbonate ion, right? So because of that, what we can more or less confirm is that when I have carbon dioxide gas, then carbonate is present, right? Carbonate is present. So we know actually what we can confirm is that solid A is something carbonate, and we haven't found out what is the cation yet. Okay, so for part C, we are doing the experiment. Now for part C, you're using solid A again, and in this solid A, you're adding acid. Okay, and then you see lime water again. So once again, you can see that this is actually you are testing for CO2, right? Okay, and you're testing for CO2, and then the acid can react with carbonate. So what do you expect to see? Quite straightforward lah, huh? Right? So this is once again a test for carbonate. Okay, so once you add the acid, you will see bubbles of gas produced. Right? When you add the acid, you're going to see a lot of gas produced. Then after that, you're going to see the white PPT in lime water. Okay, very straightforward. And because of this, then you know that gas is carbon dioxide gas is produced, and then carbonate, you confirm once again that carbonate ion is present. So we're doing 2 experiments to confirm the carbonate. Okay, now is the next part that is actually very important, because we haven't found out what is the cation ion. Okay, now over here you would also have noticed that other than these 2 observations, you will see that this particular solution has turned color, right? The solid actually dissolve and then you get a different color, right? So solid A dissolve, right? And then giving a blue solution. All right, you may see a little bit green or blue, right? But it should be mostly blue, right? And you're going to use this blue solution for your next step. And this next step, very straightforward. You are going to add aqueous ammonia until no further change. So once you see aqueous ammonia, you can be sure that this is actually a test for cation ion. Okay, and what you will see is that you're going to form a blue PPT, and this blue PPT is soluble in excess, giving a dark blue solution. And from this, then you know that Cu2 plus is present. So from here, we will know that this is actually copper 2 carbonate, right? And copper 2 carbonate is actually a green solid, okay, a green powder. Okay, so that's it for question 4. Okay,